Hello everyone. So this session, let's just review the sequence and a series. Uh, and this we should learn in previous session, right? So the sequence and a series. Anyway, don't think about this as what your common sense, right? This is arithmetics, right? This is mathematics, so it should be by mathematic way. So let's go to first see the definition. Sequence is a set of element followed by order. Can be finite or infinite. So this is sequence. So example is what? Simple one, huh? Anyway, sequence is based on the set, right? So let me use an interesting pen. Maybe you will like it. So the set one, the first is what? 1, 2, 3. This is a finite, right? Set, and they followed by order 1, 2, 3, right? So this is sequence, and they talk about the infinite, so you can write in about 1, 2, 3, 4, etc. Right? So sorry, this will be like this way. Okay, so this is sequence. What is series? The series just add them together, just that simple. It can be finite, it can be infinite. So the normally for sequence we are more care about their elements. So first, second one. So when we counting n represent the first and until the nth element. And for the infinite, same. But for the sequence we use the series. Sorry, series we use s. So it's called sum, right? So the first one is what? 1 plus 2 plus 3 is 6, right? The second one is what? Later I will count. Okay. So since we are now already know what is sequence, what is series, let's go to see some example. For below sequence, choose the first six element of this set, okay, and count associated series. Okay, so the sum. So you can see this one. Definitely this is a sequence, right? Because the first number is what? First number is 3. Second number is what? Second number is 6, right? Third number is 9. Fourth number is 12. Fifth number is what? Fifth number is 15. Sixth number is 18, right? That's easy, right? So the associated series is what? Is the sum of 3 plus 6 plus 9 plus 12 plus 15 plus 18, right? Equals to what? So that's easy. I will not count it here. Let's see the second example. This also a sequence, right? Because they follow the pattern, right? Follow some pattern. So let's count in the first element, A1 until A3. Okay, so A1 is 1. 1 plus what? 1 times 1 is still 1, right? 2 is like numberless 1. Sorry, 2 plus 2 times 2, 2 square. It's like this way, right? And the 3 plus 3 square. And then 4 plus 4 square, right? 5 plus 5 square, right? That's it, right? 1, 2, 3, 4. We need 6 numbers, so 6 plus 6 square. Let's move a little here. Yeah. So that's it, right? This is the A6, right? So how about the sum? Sum, of course, is easy, right? The 6 element add together, so it's 2 plus what? This is a 2. This is a 4, 6. This is what? 9. This is 12. This is what? 16, 20. This is what? 30. This was 42, right? Let's see, just see. Sorry, it's not set. Sum. So that's it. Very easy, right? Now we go to two concept. First is the arithmetic sequence. What's called that? Why you call arithmetic is because arithmetic is more related to plus, minus, right? Times, something like that, right? So here is like each element after the first element is obtained by adding a constant, right? So which means if first element is 1, the second element is, just give example, 3, and then the third element is 5, because they talk about they have each element up that they have obtained by adding a constant. So this constant can be adding 2, this can be adding 2, am I right? So this will be 7, right? Right. So also counting 2, this will be 9, right? So they talk about this one. So this is a arithmetic sequence. Okay. This is definition. Now see example. Okay, or we deduce the formula. For nth element arithmetic sequence is an. It just took an, and an can be a1, a2, a3, right? So constant is 5. So constant is 5. So we already can know that this is an equals to a1, right? Plus what? Plus what? 5, right? The common distance is 5, and then n minus 1, right? Uh, why n minus 1? Because when n is 1 is a1, right? When n is 1 is a1, so an is 5 minus 1. So the 5 is the uh 5 is the we have a number for this. 5 is d, the difference or constant minus difference, right? So first element in the sequence is uh wait, first element you talk about a1, a1 is 3, right? So that's right. So they will ask for your associate series. Okay, so this is definitely is quite easy. So if it is just give example, we don't count it. So first is a1, so 3. The second is 3 plus what? 5, 8, right? The third will be 3 minus 1 is 2. 2 times 5, 10. 10 plus 13, right? Right? So until what? Until 3 plus 5 times a minus 1, right? Right? So this is the sequence, right? The series is what? What's the series about this one? Be careful. This series is the formula, huh? Finally, you can see the formula about this, the sequence. How we do calculating about this? So look at here. Just make this one now. Just make in between the second to last is 3 plus 5 and minus 2. Am I right? So the first to the last and the second to the second to last, if they plus together, is that same? That's counting. Okay. The first two plus is 3 plus 3 plus 5 and minus 1, right? The second is 8, right? 8, right? Plus 3 plus 5 and minus 2. Minus 2. I feel it's like it's better. Let me change another pencil. Okay, so let's see if they're really same. So we just make them as the first is let's go to a little left side, some more space. 3 plus 3 is just 6 plus 5 minus 5. It's better still use the black pen. So it can be 1 plus 5n. Am I right? And then let's see this one. So this is 11 plus 11 plus what? 5m 5m minus 10, right? 5m minus 10. So equals the same. 1 plus n. So right? So we can think about from the first item element, add the last element equals to second item, add to the second to the last, and the third item equals to third item, add the third item to the last, right? So So how many of this kind of the summation first plus how many of this? How many of this item? This is one, this is two, this is three, whatever. So totally should be n minus one, n divided by two, right? Right? Because they have n items, and every two atom will be summation, so definitely will be n divided by two. So n divided by two, and then will be what? Then will be the first plus the last, right? So first we just make it a1, okay? The last we will make it a1 plus d difference n minus 1. Okay, so equals to what? N over 2, 2a plus d n minus 1. Please remember this. This is the formula. This formula, not just anything, okay? Simple. This is the formula, so you can remember this. But anyway, if you can deduce this, definitely okay. For the second conception is geometric. Geometric here is more on the exponential. Okay, so it's sequence in which each element after the first is a multiply of the preceding item by a constant. So just give example. Wait. By a constant. Okay, so first they also have a constant. So if um, in each okay, so we think about like this way. So we definitely have a1 first, right? And then they have a common distance. We suppose there are a common distance. In fact, we are going to use d, right? So the first element is ar0, right? Because they are, right? The second is a1 r1, right? And then the an will be a1 r minus 1, right? This is an, right? So this is the set, right? Right. So what's the sum? Sum, of course, is simply a1 is the common, right? Is the common factor. So it's 1 plus r plus r2 plus until r minus 1. Okay, so this is not in counting how to deduce the formula uh, of the summation of the geometric sequence. Okay, so I just writing here. Okay, because it's out of the high school our scope, but just writing here. So Sn equals to uh, Na1. So uh, when r equals to 1, when r is not to 1, so it's A1 is 1 minus r n square n divided 1 minus r. Okay, so that's it. Okay, so thank you very much for joining the session. Wish you have a nice day. Thank you. Bye bye.